Okay, in 3b we're asked to find the distance travelled by p in the interval between 0 and 3. So the distance travelled in a velocity time graph is the area under the curve. So distance travelled is area under curve in a velocity time graph. So if we think of our velocity equation that we had here and think what the graph of that would look like, so with time on our x-axis and velocity on our y-axis. So we've got a quadratic here, a minus t squared graph. We already had back here the roots of the equation, so we know it crosses at +6 and -2. And we know it's a minus t squared, so it's going to be in that sort of shape. And we could also say the y-intercept is the value of 12. We're asked to find the distance travelled in the first 3 seconds. So we're just looking here. So we can see it's an area which is just above the axes. So we don't need to split it into 2 separate integrations. We can just integrate our velocity equation with respect to time between our limits of 0 and 3. So if you integrate your equation that you had back here, that will give you 12t plus 4t squared over 2 minus t cubed over 3. Sorry, don't want the integration sign at the beginning. So integrate your velocity equation with respect to time between your 2 limits of 0 and 3. If you then substitute 3 into that expression, you'll get 45, and then obviously if you substitute 0 in, you get 0, so it's the difference between those. Therefore the distance travelled is 45 metres.